there are a lot of sections that we want to talk about. So one is the AIDA section, right? That is the new AI and data analytics department. So we have a lot of slides and a lot of things to talk about, but yesterday we also did an event, and one of the things that's my main takeaway is that we want to do this less and we want to hear more questions. So I will finish the PPT as fast as we can, and we'll take questions later, right? And you can have more of a one-on-one interaction with all of us. So if you finish this PPT in the next half an hour, that will give us an hour or so of interactions that you guys can do with us. So AIDA, it's one of the first courses of its kind. I'm going to talk a little bit about this new course and other new courses that are there. So what ends up happening is this course, in fact, is designed to cater to industry demand. They've spoken to a lot of people, and then they have actually made this course. So what ends up happening is in your first year, you get a strong foundation in the sciences that are required for you to actually learn AI. Most engineering courses, this is what happens. Yesterday someone asked me, oh, only in my third year and fourth year I study electrical engineering, so how do I get an electrical engineering degree if I did it only for 2 years? The reason behind that is, your first 2 years are spent developing a baseline understanding of science and other relevant, specifically physics and maths and a little bit of chemistry that's required for you to understand electrical engineering. And then you move to the applications, and then you move to the theory and then to the applications, right? Similarly, in your second year in the AI course, you learn the different kinds of modeling techniques that are there, and how do you actually, make a model. And then the third sem, you will learn how to tweak that model, make it better, and deploy it in various circumstances. And in your fourth year, you would have, learned how to develop these models and train them and everything. Now you will find a real life application for this to develop a model and to use it in that space. It could be law, it could be medicine, it could be aerospace also, for example, right? Yeah, one of the things is that, it's an emerging and evolving field like we discussed just now. And I think that's true for most of the fields. In most fields today, chemical engineering, civil engineering, there's a lot of evolution that's happening. The way people do work has changed a lot. I spoke about this, right, already. So I'm just going to skip to the next slide. So, for example, this is another example that I like to talk about. Or rather Dr. Arvind Srinivas, he's the CEO and co-founder of Perplexity.ai. It's a popular search engine. Has anyone used it? Nice, amazing. Do you guys like it? Nice. So, yeah, he actually talks about, electrical engineering and how he is an electrical engineer, wanted to branch change, couldn't branch change, ended up learning how to code, participated in a hackathon related to machine learning, and then one thing led to another, and he actually went abroad for a research intern, and that's where all of this happened, and one thing led to another, and then he was neck deep in AI, and he started Perplexity, which is like a multi-billion-dollar company and only growing from here. Another thing I'd just like to talk about before handing over the mic to the professors to talk about the new courses in their departments. A lot of you have questions about which course do I pick, right? And broadly, I can tell you 3 things you'll have to consider in any institute or whatever course it is. One is you need to know what the institute gives you, right? What are the facilities available in that institute? We'll talk about this here. And again, you will have to figure out which branch. See, chemical engineering, how many of you know what chemical engineering is? How many of you think there's a lot of chemistry in chemical engineering? Okay, great. So that's right? In chemical engineering, you more or less learn how to build reactors that can have certain reactions going on in them. So your first year, you spend learning basic sciences and a little bit of mass transfer and everything. Second year, you learn applications of mass transfer, heat transfer, applications of heat transfer. And then third year, you slowly move into a place where you learn about fluid mechanics and everything. And then you start learning how to build a reactor for a particular reaction to happen. It could be a continuous stirred tank reactor, it could be a plug flow reactor, it could be a batch reactor, things like that. And in your fourth year, you actually, now you have this reactor, right? But in real life, I can't spend an infinite amount of money on this reactor. So I'll end up learning how to design a reactor in a given budget to operate at a certain efficiency, right? How much money I spend to build it, how much money I spend to run it every year. So we learn how to optimize for that and design a reactor accordingly. So that is what chemical engineering is. So what I urge all parents and students to do is pick out degrees that you know, mechanical engineering, whatever you guys think you want to do. See what are the courses that you will learn in that degree, and then look up what each course is, right? What is that exact thing you will study in that course, and you'll figure out broadly what are the subjects you need to be good at in order to be good at that degree, right? For example, chemical engineering, you need to know thermodynamics. If I very broadly put it, you need to know a lot of thermodynamics to actually be able to be a good chemical engineer, right? So it doesn't make sense if I'm not good at thermodynamics, but I'm good at physics, I'm not particularly good at thermodynamics, doesn't really make sense for me to be a chemical engineering if I don't like thermodynamics, right? You students figure out what is the individual subject, individual topics in math, physics, chemistry that you're good at. Figure out what of these engineering courses, or any course for that matter, will allow you to use those subjects and go deeper into them, and that's how you actually match yourself. And then comes the worrying about the institute and the placements and things like that. So this is how you first actually do this. Unfortunately, I wish I had known this when I was making this choice. It's only something I've discovered recently in the last year or so. With that, I'd like Professor Vardhan, do you want to talk about the new courses?
Okay, there is 3 new programs that we are introducing at IIT Madras this year. The first one we'll talk about is this program on computational engineering and mechanics. This program is about creating a 21st century engineer who can harness the full power of computation. Computation today happens through computational fluid dynamics, finite element methods. There are electrical engineering tools that do computational modeling of a particular circuit. For example, a mobile phone PCB, before even the first piece is built, a computer model is made of the whole system or a subsystem, and it is exercised in silico, as they call, in silicon, before you go build the first prototype. The Boeing 777, which is a full flying aircraft today, the first ever prototype that was built was actually sold to a customer. The entire plane was designed in a computer, tested in the computer, and put out for people to use. So these computational tools are very important for life in general, engineering life in general. This program emphasizes that. You can see there's a whole progression of curriculum that it blends electrical engineering, it blends mechanical engineering, material science, computational engineering, data science, AI, and then this idea of a digital twin. A digital twin means, let's say, you take any complicated engineering system out there, let's say a power plant in Ramagundam or Singareni, Ramagundam power plant. If I want to know the health of the power plant or of the whole system or any subsystem, I need a computer model that is at any instant of time an exact replica of the real power plant that is generating power. So this in silico model of the exact power plant that is out there is called a digital twin. In 10 years, you will have a digital twin of yourself in a computer model in some doctor's computer. Okay? It's getting to that point where your personalized model, how is your heart beating, what is the food you are eating, as a result, what is the stress strain on your body? There's a model in which the doctor is able to sort of do a lot of what-if tests. One of my colleagues works on surgery, modeling surgery. So you really play out different scenarios for the surgeon before the surgeon picks up the first knife. And in the computer model, you eliminate the things that are not going to work out and really find the optimal surgical process to actually exercise on the patient. This is the power of digital twins. And then finally, the core philosophy is to do an engineering first model. Meaning, if I want to bring this whole power of perplexity, AI, data science, to go beyond just writing poetry, answering questions about which branch I should choose, you go ask, should I choose IIT Roorkee Civil Engineering or IIT Bombay, some other branch, or IIT Indore Chemical Engineering? It will give you an answer. Now, is it standing by its answer? No, the risk is all yours, right? Going beyond this sort of almost for entertainment only. AI today is practically at this level. If I want to invest AI into a real engineered system where we can bet lives on it, you need people who understand hard engineering, real world engineering, and then bring the world of AI together and closer to that. That is what this curriculum practically does. This slide deck, as Nikhil said, will come to you. You can go through this in some detail later on. Get ready to lead the next wave of engineering. That's sort of broadly. We've developed this curriculum with a lot of engineering input, a lot of industry input, and we believe it's perfectly positioned for the world at large to really start to see the confluence or the marriage of all of the disciplines of engineering with the world of AI. We believe this is the one program that will make that happen. From seeing the conversations on social media and Ask IITM, we really believe this is going to be positioned at a very high level. Even from the students, we've seen a great demand, and we'll certainly hope to see the best of all of you come be part of this program in my department as well. Okay. If you have any questions on this program, since it is new, I'm very happy to answer them as well. Yes, sir. Was owned by the Applied Mechanics and Biomedical Engineering department. That's the department I come from. That's correct. And just to give you a little bit about the department itself, our department is probably the most interdisciplinary department in the entire country. We have about 38 faculty members with training in 12 different disciplines. I'm a mechanical engineer. Varadhan is a biomedical engineer. We have physicists, we have civil engineers, we have aerospace engineers, we have electrical engineers, we have instrumentation engineers, we have doctors who are professors of practice. It's a very diverse department, and all of us have chosen to come together to create this program and run this program. No, this is a regular department. It's like any other department. No virtual. It's as old as IIT. This department was intended to be an interdisciplinary department from 1959 when IIT Madras started.
One thing I'd like to add to this particular slide, and as Professor Mahesh suggested, is that just like how this course has been set up in consultation with a lot of industry personnel, all other courses as well have industry connection to it. Professor, what is the exact term they use? Advisory committee or something like that?
Yes, so most programs have an industry advisory committee, but this program was formed ground up with their inputs also. So we believe this will be, and in fact, most of the industry, we talk to leaders of a lot of industries, say, one of the automotive companies, Saint-Gobain, we have talked to people from electronics, fabrication. The one common thread we heard from all of them is, I wish I had this program when I was 18-year-old. And I would have loved to jump into that program. So that's sort of the overall thinking. It blends the world of computation with the world of real world engineering. At the undergrad level, you can then specialize into any one of the many different engineering departments, or you can be the systems level thinker, which is a very, very valued skill in the industry today. I can buy subsystems, really. I can buy a pump, for example. I don't need to design a pump today in India. I can buy a pump wherever I need some pressure generated. But to buy a pump, buy some other component, buy 2-3 components and make a system do something reliably, that's a systems level thinker. And that system design skill requires this computational foundation. Okay, any other questions? So, can we consider this as AI plus robotics in some sense because of the electives? One thing we have done at IIT Madras is, as Nikhil said, 40% of the total credits are in the student's hands. So irrespective of what you are studying for your parent discipline, parent degree, you can use that 40% to specialize in AI or robotics or whatever else. This program is beyond even AI and robotics. So you can consider it in that sense. But so if you want to specialize in AI for robotics, certainly this is a great starting point because it brings mechanical engineering, it brings electrical engineering, and it brings the world of AI into one person. So certainly that is one of the domains in which you can exercise this skill set.
In this computational engineering, what I understand is you make the marriage of the engineering problems, you embed it with the AI and try to get a solution out of it. So with the very basic engineering subjects that are taught here, do we expect the student to understand the problem, not really go deep into it, with the common sense and the basic engineering that is taught? He is expected to understand the engineering problem, and then with the AI skills or the computational skills, doing a marriage with both these two, and then get a solution out of it. Is that what is expected out of a student or someone who is into this field?
So I will come back, answer your question in just a couple of minutes, but I want to generalize your question if you don't mind. At the end of 4 years of any engineering, what do I expect that person to be able to do? Okay? Let's say somebody studied BTech civil engineering. That person, let's assume, came from a rural background and the first engineer from that village. Okay, we see these stories at IIT Madras all the time, by the way. Our students are not at all from the urban areas by majority. You'll be surprised. Okay, side deviation. Now this village is excited that the first engineer has gone out of their village, gotten a BTech in civil engineering. The Sarpanch comes and says, Babu, ikkada oka chinna kalava paartondi. ఈ కాలువ మీద తెలుగు అందరికీ అర్థమవుతుంది కదా, ఓకే పర్వాలేదు, ఐ వాంట్, ఓకే బాబు ఇక్కడ చిన్న కాలువ పారుతోంది. ఐ కాంట్ స్పీక్ ద సర్పంచ్ ఇన్ ఇంగ్లీష్, వీఆర్ డూయింగ్ దట్ పర్సన్ ఇన్ ఇన్జస్టిస్. ఇక్కడ కాలువ పారుతోంది కదా, ఈ కాలువ మీద ఒక చిన్న వంతెన కడితే మన బండ్లన్నీ కూడా దాని మీద వెళ్ళి మనకు చాలా పెట్రోల్ మిగులుతుంది, ఎఫిషియన్సీ వస్తుంది. ఒక చిన్న కల్వర్ట్ ఒకటి కట్టగలవా, నువ్వు సివిల్ ఇంజనీరింగ్ 4 ఏళ్ళు చదివి వచ్చావు కదా అంటే అబ్బాయి కట్టగలడు అంటాడా? కెన్ యూ థింక్ దట్ గర్ల్ ఆర్ బాయ్ కెన్ బిల్డ్ అ small culvert there? Culvert is just one big pipe. You put you put mud on both sides. You raise to make sure it goes over nicely. Do you think that that kid is able to, that not kid, but the 4-year-old, the 4-year BTech graduate can say, yes, sir, it will oka 30 lakhshalu avutundi, నేను కట్టి పెడతాను అన్న ధైర్యం ఆ అబ్బాయికి కానీ అమ్మాయికి కానీ ఉంటుందంటారా? ఎందుకు లేదు? 4 years చదివాడు కదా సివిల్ ఇంజనీరింగ్, కావాల్సిన మెటీరియల్ అంతా చదివాడు. There is a structural engineering course, right? There is a fluid dynamics course that will help them understand flood వస్తే ఎంత పెద్ద కల్వర్ట్ కట్టాలి అన్నది. హైడ్రోడైనమిక్స్ కోర్స్ ఉంది. కావాల్సిన మెటీరియల్ అంతా ఉంది. వాట్ ఈస్ మిస్సింగ్ ఎలిమెంట్ ఏమిటంటే నాట్ హ్యావింగ్ డన్ ఇట్ బిఫోర్. రియలీ అట్ ద ఎండ్ ఆఫ్ ద డే ఒక్కసారి చేసిన తర్వాత రెండో కల్వర్ట్, ఒకసారి చూసిన తర్వాత రెండో కల్వర్ట్ నేను కట్టగలను అంటాడు. నువ్వు ఫస్ట్ కల్వర్ట్ నువ్వు ఇంకోళ్ళతో నించొని చూస్తున్నప్పుడు, ఏది రెండో కల్వర్ట్ నువ్వు నీ అంతటి నువ్వే వెళ్ళి కట్టడానికి, ఫస్ట్ కల్వర్ట్ నువ్వు ఇంకెవడో కడుతూ ఉంటే నువ్వు చూస్తున్నావు, దానికి నీకు జీతం ఎందుకు ఇవ్వాలి? ఎవరైనా నీకు జీతం, నేను నించొని చూసి నేర్చుకోవడానికి నీకు అసలు జీతం ఎందుకు ఇవ్వాలి? లోకం అట్లా ఉంది. ఫస్ట్ ఇయర్ సాలరీ ఈజ్ ఫర్ యూ టు సిట్, వాచ్ అండ్ లెర్న్. You should be considering yourself fortunate that someone is paying you for that, right? So back to your question. The answer is yes, that person will have the basic foundational tools to then branch off into any discipline that that person chooses. Like for example, I want to do a digital twin developer for a high-end medical device. For example, the state of care in certain forms of cancer is called proton beam therapy. Okay, where you are able to completely localize and destroy a certain tumor using a proton beam. So I want to know the health of that proton beam machine. Daniki I need to build a computer model of the proton beam machine. So at the end of 4 years, will this person be ready to build a model of a full proton beam machine? Probably not, but they will know the foundational principles that they can then fit into a team that is doing this, learn, contribute. And our guess is in hard engineering disciplines. Civil engineering is a particular case in point, most mechanical engineering, etc. It will take you 5 to 10 years of really gaining this domain expertise. After that, because until then you are sort of learning and contributing both. It's not like you're only learning passively, right? You're learning and contributing, but once you've acquired a certain domain skill, your own value to any company or to the world outside will go up. After you watched 10 culverts being built, you have sort of done this with your own hand. If you then say, I'll go start off my own company to build rural culverts, you are in business. You will make far more money than anybody that didn't choose this path after that. But if you are part of a team that built one culvert in one village, then you said, culvert building is not my trip in life. Well digging, borewell digging is my trip in life. Then you go switch to a team that digs borewells. You learn you are a part of a team that dug one borewell. Then you say, no, not even borewell. Now I'm going to learn how to build, homes, apartment buildings. You go do that for 1 year. You go do something else for another year. You are good for nothing at the end of the 10 years. Even though you've done some small things here and there, you would have rather been better off if you developed this deep expertise in one discipline. దానికి కొంచెం పేషెన్స్ కావాలి. షిరిడి బాబా దీని వెనకాల ఉంటుంది చూసారా, శ్రద్ధ సబురి. శ్రద్ధ ఇస్ ఫెయిత్, సబురి ఇస్ పేషెన్స్. కొంచెం పేషెన్స్ కావాలి మనకు. దట్ ఒక పర్టికులర్ డిసిప్లిన్ నాకు చాలా ఆశగా ఉంది, బాగుంటుంది అనిపిస్తుంది. నెక్స్ట్ 10 ఏళ్ళు దాంట్లో నేర్చుకుందాం. నేర్చుకున్న తర్వాత మన వాల్యూ తప్పక ఎక్స్పోనెన్షియల్గా ఉంటుంది.
One thing is that there are a lot of sections that we want to talk about. So one is the AIDS section, right? That is the new AI and data analytics department. So we have a lot of slides and a lot of things to talk about. But yesterday we also did an event, and one of the things that's my main takeaway is that we want to do this less and we want to hear more questions. So I will finish the PPT as fast as we can, and we'll take questions later, right? And you can have more of a one-on-one interaction with all of us. So if you finish this PPT in the next